Hello everyone. In this video, I have compiled the 4 problems on the rotation of the rod about its axis passing through its center of mass, both in horizontal plane as well as in vertical plane. In the problem shown here, the two beads are initially at the center of mass position and the rod is rotating with the angular velocity omega 0. Slowly, due to centrifugal force, the bead will displace towards the end position. It is asking when the bead reaches the end point, what is the angular velocity of the system. It's a simple problem. Since there is no external torque acting on the system, the angular momentum of the system will remain conserved. Initial moment of inertia of the beads will be 0 at they lies on the axis of rotation, while rod has moment of inertia ml square by 12. Now when both beads reaches the end point, they both have moment of inertia 2 ml square by 4 and the rod has moment of inertia ml square by 12. So total moment of inertia of the system will be ml square by 12 plus ml square by 2. Hence, applying law of conservation of angular momentum, we can get the final angular velocity as capital M divided by capital M plus 6 small m, omega 0. Now come to the second problem. Here the rod is kept on horizontal table and it is free for rotational and translational motion. 2-point mass of m and 2m hits as shown in figure. After hitting the rod, they stick to it. It must be noted here, after collision, the center of mass of the rod is not changed. Now once we consider the rod and the 2-point mass as a single system, all the forces acting during collision are internal forces, hence linear momentum of the system will conserved. Initially the rod is at rest, only the masses are moving in opposite direction, hence initial linear momentum will be 2 mv minus 2 mv, that is 0. Here it must be noted that linear momentum is a vector quantity, hence if we consider the linear momentum of mass 1 as positive, we have to consider the linear momentum of mass 2 as negative. Now if we consider the center of mass moves with a velocity vc after collision, after applying the conservation of linear momentum, we get vc as 0, means rod will not perform any translational motion. So the whole system after collision will perform only rotational motion about its principal axis. Let the angular velocity of rotation is omega. Now since there is no external torque acting on the system consisting of the rod and the 2-point masses, its angular momentum will also be conserved. Initially the angular momentum of the rod will be 0 and only the masses have angular momentum, that is mva and m2v into 2a. After collision the system rotates. The moment of inertia of the rod will be 8m into 6a square divided by 12, while that of masses will be m2a square and 2m into a square. Hence, moment of inertia of the whole system will be sum of these three. Once we apply law of conservation of angular momentum, we get omega is equal to v by 5a. Also, after collision, the whole system has only rotational energy and its value will be half I omega square. So total energy of the system comes as 3 by 5 mv square. Now here in this third problem, a rod is pivoted at its center position and is free to rotate in vertical plane. The rod is initially at horizontal position and an insect falls over it as shown in the figure. So the rod gains angular velocity and rotates in the vertical plane. Now when the rod is in horizontal position and insect hits it, in this case, till the collision occurs, there is no external torque acting over the rod and insect. Hence, we can apply law of conservation of angular momentum to find the angular velocity of the system just after the impact of the insect. But once the rod insect system rotates vertically under influence of gravity, the torque due to gravity on rod insect system is an external torque, hence angular momentum will increase. And we can apply the equation, the rate of change of angular momentum is equal to net torque applied by the gravity. Now at the time of the landing of insect over the rod, we can apply the law of conservation of angular momentum to get the initial angular speed of the rod insect system. Once the system performs the vertical rotational motion, we use the equation external torque is equal to rate of change in angular momentum, thus we get the desired result as asked in the question. Now here in the fourth problem, a rod is kept on horizontal floor and two beads hits the rod as shown in figure. Here also, after collision, the center of mass of the rod is not changing. Now during collision, there is no external force acting over the rod and bead system. Hence, after applying the law of conservation of linear momentum, we get the speed of center of mass of the whole system as 4 meter per second. Now, on hitting the beads with different speed, produces torque over the rod, and the rod starts rotational motion also. But once we consider rod and bead as a single system, the torque produced are all internal torques. That's why the angular momentum of the whole system will remain conserved. Applying law of conservation of angular momentum, we get the final angular speed of the system as 2 radian per second, and hence we can calculate the loss in kinetic energy of the whole system. So this is all about today's video. If this compilation looks useful to you, please give a like button and please subscribe my channel. Thank you very much.